Hello, my name is Haresh Malkani. I'm the Chief Technology Officer at CESMII. You heard in the previous presentations that CESMII is made up of our members. That's the power of this institution, doing collaborative work. So what I'm going to speak about in this session is what is that power of the ecosystem that we have. And hopefully at the end of this session, you will understand how CESMII works and how CESMII creates value for our members. Now, if you look at how CESMII is made up, you can see that we have manufacturers, we have systems integrators, we have application vendors, academia, and machine builders who basically form the community or the ecosystem of CESMII. And this is where most of the expertise resides and a lot of collaboration takes place within the institute as we perform our work. What is shown on the left-hand side here are the key things that CESMII provides to our members and to our ecosystem so that this great work that is being done by the institute actually gets done. So if you look at these three elements here, the first one is what we are calling the building block technologies of smart manufacturing. Now, what do I mean by that? Now, if you look at a manufacturing process, right, there are a lot of building blocks that essentially make up what we are calling smart manufacturing. So if you look at the ability to capture data through sensing, the ability to contextualize that information so that it's some actionable information that comes out of the data that you're capturing from your process. Based on that information, now you can actually do some analytics, can do some assessment of why things happened the way they did, right? Then you develop some insights based on that. Then you move over to the area where now you start predicting what might happen next. And that's all about the modeling and simulation that takes place on the site. And then eventually what you want to do is that take the output or the benefit of doing all this and apply it to your control systems on the manufacturing floor. So these building blocks, they don't necessarily work in isolation. What makes them work and connect well is some sort of a platform that enables these different components to work seamlessly and interoperate. Now, one of the requirements there is that as you gather data and information in this loop and you use that information through the different blocks, you want to maintain context of that information. So this diagram essentially says that, okay, we have smart manufacturing as these building blocks, and that the information that needs to flow between them is as critical as the blocks themselves. So that's what we call smart manufacturing. So these are all the building block technologies. Then the next thing is this SM innovation platform, or the smart manufacturing innovation platform. And this is the technology that enables movement of information in context. And this has basically 3 or 4 layers, and we're going to have a separate session that goes into the details of this. But you have the edge connectivity. This is where you're actually gathering information from your processes and from your assets on the shop floor. This is basically the core of our platform, where a lot of the standards, de facto standards, are being created and used so that you can manage the data, you can contextualize the data, and you can make it available for applications that consume the data, right? And this platform has a marketplace here on the right-hand side where we gather the collective IP, the collective information that is created through the institute, and make those components available through our marketplace. And they could be profiles or applications. And we'll talk about this in a later session in detail. The third piece of this that CESMII provides is the education and training framework. And it is equally important to have well-trained, well-educated, well-versed workforce in smart manufacturing, because technology alone is not sufficient to make a successful SM solution deployed and proliferated. So this is where we talk about the different types of audiences. You may have, people who are at the management level who are making decisions. You might have the skilled workforce or the engineers or the technicians. And then we also have our professionals and the technology vendors who are part of our ecosystem, our extended ecosystem. And all of these audiences need to be considered as we develop the content, as we certify the content, and as we deliver the content. So this is the part of the ecosystem that works on education and workforce development. So having all these things together on the left-hand side and our partners on the right-hand side is basically how this ecosystem works. Now, what do we do with that? So if you look at all of our members that constitute the left side of this picture here, with the expertise and the collaboration, we basically have these tools available to them, and the way we execute on the work that needs to be done is that we have co-funded requests for proposals. We launch projects based on these team members on the left side, and then we create CESMII produced content. We create technologies that are useful for our project teams and our members at large. And then we endorse that and we put it out into our marketplace. So on the right-hand side, we have the technologies that are part of the marketplace. And then we have the SM Education Catalog, which is the training content that we produce. So this is basically the pathway that's taken to create the content and create the technologies. But then at the same time, the same content and technologies can now be reused by our ecosystem of members. So this is how our the creation of technologies, creation of the education content takes place, and then in return, how our extended ecosystem leverages that content. Now, why are we doing this, right? So what? All this work that is going on, we have to have some impact on our members, right? So if you take all of these technologies and workforce development content, basically what we are trying to do is make an impact on the performance, productivity, and precision of the manufacturing process. What do we mean by that, right? So these tools on the left-hand side basically allow you to make real-time decisions because you have visibility to real-time data. We have predictive analytics that can be done based on the information that you gathered. You can optimize the control systems based on that. You can do process analysis, process optimization, and of course simulation, because you want to be able to recreate what the actual process is doing so that you can make some offline decisions based on that. But the result of all this work that takes place here in the middle is that you will eventually get a optimized manufacturing process. You will improve the performance of the equipment or the flow path. You will improve the productivity of an individual workstation or an individual process or the entire workflow of the plant. You will reduce waste. You will improve the yield, and you will improve the quality, right? So by utilizing some of these smart technologies on the left-hand side, we are impacting a whole bunch of things here on the right-hand side. And eventually, when you do that, you will end up getting an improvement in energy productivity. Now, in some cases, that productivity comes directly as a result of utilizing these technologies. In other cases, it's more of an indirect impact on energy. But nevertheless, that's an important impact or return on investment for our members. Now, this is not done in isolation in the sense that the types of things that we have to do to make an impact on our manufacturers is driven by a institute roadmap. And if you look at this diagram here, we have basically 4 pillars of that roadmap. The first one is around the enabling technology. So these are all the building blocks that we talked about before. And in each of these cases, we actually have a set of swim lanes and activities and focus areas and deliverables that represent that particular pillar. The second pillar is around the innovation platform. So again, movement of information, contextualization of information, profiles, which you'll be hearing about later on. The third pillar is around the education. and workforce development, again, content development, training. And the fourth one is the SM ecosystem integration. And this is where we have a network of networks. We have smart manufacturing innovation centers. We have the ability for our members to be collaborating and working together to create value for the entire ecosystem. And all of these elements in the roadmap are very strongly connected to our goals of the Institute. And these are around the energy efficiency, they are around reducing the cost and complexity and time to deploy smart manufacturing systems. We are driving the democratization of smart manufacturing, so we are driving towards significant adoption of technology. And then, of course, improvement in the energy productivity for U.S. manufacturing. And these are all highly integrated, so you may have activities that are going on one part of the roadmap that are strongly linked with some other parts of the roadmap. So that ensures that the work we do has a holistic feel to it. Now, again, in terms of collaboration, again, CESMII is not working in isolation. We are collaborating heavily with some of the other institutes of the Manufacturing US Network. And here are some examples of that. With RAPID, which is the Modular Chemical Process Intensification Institute, we've had several joint webinars and workshops. So there's some cross-pollination of knowledge and potential technologies that we use by each of the institutes. With the Advanced Robotics Institute, we are moving towards dovetailing projects, so where one of the institutes will fund one part of the project, the other institute will fund a following part of the project. So we are dovetailing those projects. We have a great example of that in our portfolio today. With the Cybersecurity Institute, CyManII Institute, we have a representation on the governance board and the technology advisory committee. And that allows us to make sure that as we proceed on our roadmap and CyManII proceeds on their roadmap, that we have good cross connections and alignment with how things are getting linked together. And you'll hear a little bit more about our collaboration and the Cybersecurity Institute in a few minutes here. And last but not the least, we also have a strong collaboration with the MXP Institute, which was formerly DMDII. And here we are collaborating on technologies and test beds to drive interoperability. And this is an important piece of what CESMII is driving towards and what MXP is also driving towards. So you will hear from both the Cybersecurity Institute and the Department of Energy about how we are making an impact on their goals. Now, above all of that, we are also involved in a cross-institute effort around creating the manufacturing guard, and you can see more of this on this website that's given down below. But again, the idea here is to come together and make a national impact on all of the critical things like supply chain, the manufacturing strategies, and how to make a strong workforce for U.S. manufacturing that's well versed in most of these advanced technologies that the institutes are addressing. So come and join us. This ecosystem is open. You can bring in your expertise, your people, your technologies, and join us. And essentially, to reuse some of the words used by Steve Jobs, make a dent in the smart manufacturing universe. So hopefully we'll be able to do this together. Thank you.
Hello, my name is Howard Grimes. I am the Chief Executive Officer of the Cybersecurity Manufacturing Innovation Institute. And we are partners with CESMII, which I'll talk a bit more about later. But the Cybersecurity Manufacturing Institute, or CyManII, is a very recent, we're only 1 year old today, or this month. We're about a year old, and we are focused on meeting manufacturers where they are today to make them much more hard or harden their infrastructure against cyber attacks, but also working with them to build a future state of cybersecurity that really protects their infrastructure in a number of different ways. So we are, several things that differentiate us. Like all the MIIs, we are a national institute. We have a footprint in over 23 states, including California, with CESMII, and 2 universities there as well. But in addition to that, we operate, close in hand with 3 of the national labs, the Idaho National Lab leading in industrial control system, cybersecurity, the Oak Ridge National Lab, a leader in advanced manufacturing, and Sandia, a leader in both cyber and physical security of supply chains. So we amalgamate or integrate a huge amount of talent in both advanced manufacturing and in cybersecurity. And our institute represents the largest public investment by the federal government in cyber defense capabilities. And in order to execute our mission, it's essential that we understand the threats and what's out there. So U.S. manufacturers are the #1 target for nation-state sponsored cyber attacks against our country. And it's our job to work on finding solutions and innovations for that, meeting you today, but embracing you in your journey into a future state of far more cybersecurity than is even possible using today's systems. So that's our main charge. In order to execute that mission, it's imperative that the Institute, or CyManII, operates from a threat-informed perspective. And that's one of the things that really differentiates us from any entity out there really on cybersecurity, especially cyber for manufacturing, is that all of my leadership and most of my technical leads have the necessary and appropriate security clearances to truly understand the threat vectors, the actors, and the evolution of those. So as we work on securing your current systems, we bring a very threat-informed or cyber-informed perspective to that work. And as we build new architectures and new innovations, we integrate and design that from that cyber-informed, secure by design perspective. We are delighted to be able to work with CESMII. They have been one of our key partners during our negotiations as well as during our first year of operations. But the marriage, if you will, between the Smart Manufacturing Institute and the Cyber Manufacturing Institute, it really brings a new approach to your perspective as a manufacturer. How do you get increased energy productivity, cost savings, in other words, by increasing your equipment productivity. But how do you do that in a secure manner? How do you cyber secure your operations? The reason nation states are so focused on U.S. manufacturers is it's an ideal way for them to decrease their own spending on research and development. They can simply acquire our designs and the outcomes of our research and development and deploy them very much more quickly than if they had to go through the R&D process. But it's imperative that we protect those designs and that intellectual property. And one of the key foci of CyManII is just that. Another reason that U.S. manufacturers are such a target is that there's critical ways that nation states can disrupt our supply chains, and that is of key interest to them. And whether you've been attacked or hacked already or not, you can take it from me that there are vulnerabilities in your systems that you are definitely exploitable at a given point in time. And CyManII is here to help you identify those vulnerabilities and cyber secure your operations against those vulnerabilities. Again, we're delighted to work with CESMII. They really represent an ideal partner for us because they represent all the innovations around smart manufacturing, but that marriage to how you make smart also secure, and doing that in a secure by design manner is really a vehicle for the future. So thank you again. Thank you, CESMII, and I'm delighted to be here and represent CyManII in this meeting.
Hi, my name is Sudarshan Rajuri. I am from Department of Energy, and I had the pleasure of working with CESMII leadership for the past few years in managing this institute from the DOE side. Welcome to this important annual meeting. I know that we are meeting virtually this time, and hopefully next time we'll all be meeting face to face. As part of these opening remarks, I thought I'll show and share some thoughts on why smart manufacturing is the future of manufacturing. This slide is busy, and I'll try to explain it step by step. The centerpiece of this is cyber physical system, and which is the actual smart manufacturing platform, which is bringing information technology and operational technology together. So this platform, which is the cyber physical system, will be interacted by many users and stakeholders, starting from designer, manufacturer, shop floor workers, supply network, manufacturing service providers, and eventually all the way to the end users and consumers. So the way that they interact with this is through the standards, protocols, and best practices. So you can see them in those blue lines. And this cyber physical system will be built on design principles, interoperability, reliability, safety, cybersecurity. All of that will be designed in a way that it is part of the cyber physical system, not as an afterthought. And this cyber physical system is enabled through different technologies for flow of elements like information, workflow, energy, and material. These enabling technologies, as we all know, sensor technologies, advanced and smart sensors, sensor networks, computing at the edge level and all the way to the cloud computing level, and also including the storage of this information. Controls and communications. These enabling technologies is the centerpiece in enabling digitalization, which is the new business model for manufacturing, which takes it from simple automation to all the way to autonomy. So there are various technologies for digitalization. For example, maintenance and manufacturing data acquisition system, how do I fuse this information, human system interface, digital twin, digital thread, modeling and simulation, and especially AI and machine learning, which enables autonomy. Once you have these enabling technologies, cyber physical platform, based on this design principle, we will then provide the capabilities like energy efficiency of manufacturing, material efficiency of manufacturing, production scheduling, optimization and scheduling, and all more importantly, how do I bring in workforce development and training for the next generation of manufacturing engineers. CESMII, as you all know, has a different investment portfolios to cater to all of that. They have platform technology projects, they have innovation projects, they have capability projects, they have enabling R&D technology projects, which are slightly larger projects, application projects, which are basically using the technology developed by CESMII to test them. And then finally, they also have something very important called Smart Manufacturing Innovation Centers, which are essential for delivering services to the members. So we should think about how we are bringing manufacturing domain to data analytics domain. And in fact, we should always think every manufacturing problem is not converted into a machine learning problem, but it's actually the other way around. By applying manufacturing, an application of manufacturing to AI and machine learning, we actually give feedback to AI and machine learning to improve that. So not only we are using them as tools, but also providing how those AI and machine learning have to be tailored for manufacturing. So the essential for making this CESMII as a success story is developing case studies and test bed. So to just give you an idea, to starting with the simple analytics and sensing and modeling and simulation for a particular problem, you may use existing technology or develop new technology from the new projects. So that will be used to develop enabling technology requirements and new capabilities at the level of lab and pilot study, so to create different test beds. And then based on those test beds like Lego pieces, reusable test beds, you can combine them and create a replicable test beds. And then extend it all the way from shop floor to plant level, the enterprise network level in terms of supply chain. So all of this will have different technology readiness level, and CESMII is touching all aspects of this through their projects and investments. So to extend on what I just said in terms of case studies and exemplar case studies, let's take some few simple examples and one of the important projects that CESMII is doing and investing. Here is a small manufacturing of cement, and the next future will be smart cement manufacturing. If you look at the entire process step of cement, one of the important aspects of cement manufacturing is clinker production, where the use of fuel for process heating and the efficiency of that is not enabled with the new technology. There is a great potential for smart manufacturing technologies in terms of sensor technologies, and invest them in this to improve this cement production. We are also going to make sure that the decarbonization can also happen, not only at the efficient use of fuels for process heating, but also changing the chemistry of the cement manufacturing itself. So here is one example how cement manufacturing will become smart manufacturing. The second example, that project they have is steel manufacturing. You can see the entire steel manufacturing process. I just wanted to highlight one where is one of the critical problem is when they're doing a continuous casting for steel, this particular thing gets clogged, and this costs a lot of money and downtime. One of the project is looking at how we can use these new technologies to predict even before the clogging happens, to predict that and then adjust the process flow in a way that you can avoid this kind of downtime, unnecessary downtimes. Here is an example of how smart manufacturing technology is helping heavy industries like steel. So CESMII also has a project on how you can look at food processing. This is where the importance of CESMII is, how these reusable pieces of technology that they developed in one industry sector can be used in other industry sectors. Here you can see the flow of the products in yogurt production, and they have a project with General Mills to see how these assets can be optimized for energy, for downtime, for predictive maintenance, and also to look at what kind of new technologies can be implemented so that they produce the product right the first time. So we are also looking at batch processing in terms of biopharma, which is monoclonal antibody manufacturing. This is very critical for pandemic situation, and smart manufacturing also enables new way of looking at this, and CESMII has a project in this area. So now you can see that the flavors of different technologies that I have just shown, CESMII, in fact, through smart manufacturing, connects with other manufacturing initiatives like resilient manufacturing, adaptive manufacturing, sustainable manufacturing. All of that is a cross-cutting set of technologies that smart manufacturing helps. So I definitely believe CESMII is poised to become the center of excellence in smart manufacturing. I wish you all the very best for this annual meeting and the rest of the 3 days. And I know that you have a good agenda and good speakers. I wish you all the very best. And first of all, I thank you for opportunity to speak to you, though virtually, next time face to face. Thank you very much.